In this video, we're going to go over how to evaluate the following limit, where we're asked to evaluate the limit as x approaches infinity of the square root of x squared minus 5x minus x. So first, as always, we can try to do direct substitution. And so by doing that, we'll have infinity squared minus 5 times infinity minus infinity. And so literally this is just infinity minus infinity, and this is an indeterminate form. And whenever you have an indeterminate form, usually you have to use the L'Hopital's rule, where you take the derivative of the top and divide by the derivative of the bottom. However, in this case, we don't really have a fraction in this original function. And even if you were to try to convert this into a fractional form, it might even become more messier. So another way you could go about doing this is by multiplying by the conjugate. So we can try to do that here. So we can say the limit as x approaches infinity of the square root of x squared minus 5x minus x multiplied by its conjugate, which is going to be x squared minus 5x with the opposite sign of plus x, divided by the conjugate again. And so by doing this, we have a difference of squares at the top because the first term is the same and the second term is the same as well. We just have an opposite sign in the middle. And so recall, when you multiply two square roots together, the square root just cancels out, and then we're just going to be left with whatever is inside. So we get the limit as x approaches infinity of x squared minus 5x, and then multiplying the negative x and the positive x together, we get minus x squared. And then we still have the bottom, which is the square root of x squared minus 5x plus x. And then we see that the minus x squared simply cancel out, and we're left with the limit as x approaches infinity of minus x all over the square root of x squared minus 5x plus x. Now, we're closer to the solution. However, if I plug in infinity right now, I'm still going to get an indeterminate form of infinity over infinity, and that just doesn't work out. So my goal right now is to try and possibly get rid of this x as well as some of the x's in the denominator. And so to do that, we can just divide both the numerator and the denominator by x. And so by doing that, we can get the limit as x approaches infinity of minus 5 all divided by x squared minus 5x divided by x plus x over x, which is just plus 1. And so I'm going to move this to the side for a second. And I want to try and get rid of as many of the x's as possible. Now, one useful trick we can recall is that x is the same thing as saying the square root of x squared. So I could rewrite this as the square root of x squared minus 5x divided by the square root of x squared. And I could combine this together to say the square root of x squared minus 5x all over x squared. And so I can now split this up into like two different fractions, where I get x squared over x squared minus 5x over x squared. And so this is just going to leave me with 1 minus 5 over x. And this is perfect now, because if I plug in infinity, I'm no longer going to get an indeterminate form. So I'm going to get the limit as x approaches infinity of negative 5 all over what we just did. So 1, the square root of 1 minus 5 over x plus 1. And now we can get rid of the limit notation because I'm going to plug in infinity now and see what happens. So we get negative 5 all over the square root of 1 minus 5 over infinity plus 1. And so what happens to 5 over infinity? Well, this is just going to approach 0 because you have a small number divided by a huge number. And so this is now going to give me negative 5 all over 1 plus 1, which is just negative 5 over 2. And so this would be your final answer.